Hi everyone, today we are going to discuss about the database design. Database design is a fundamental component of database development system lifecycle. It happens to be of the requirement collection and analyzing. So, database design can be defined as the process of producing a detailed data model of a database system. What do we mean by a detailed data model? As we are going to explain later on the data model, there are some models that we use to show our entities, attributes, and relationships among the entities at each level of the database design. So, database design is used to describe many different parts of the design of an overall database system. The main objective of a designing database is to create a design that will support the enterprise's mission statement and mission objectives for the required database system. The reason behind designing database is to accommodate the information needs or queries of the users for a defined set of applications and support the overall operation and objective on enterprise. Factors to consider during the process of database design are determining the relationships between the different data elements, creating a logical structure about the data on the basis of these relationships. So we have many different types of approaches for developing any database. The first approach is called top-down method, which starts from the general and moves to the specific. The top-down database design approach starts with the development of data models that contains a high-level abstractions, which are the entities and relationships. Then successive move to the top-down refinement are applied to identify low-level entities, relationships, and the associated attributes. The ERD model is an example of a top-down approach and is more suitable for designing of complex database design. The process of specialization to refine an entity type in subclass is another example of a top-down database design. As you can see from this picture, it's like you are going to start with the conceptual your idea about the model, and then you are going to do your entities. You are going to identify your entities, and then you will identify by your attributes. The bottom-up method begins with the specific details and moves to the general. This approach starts with the fundamental level of attributes, which are the abstractions, that's the properties of entities and relationships. It then combines or adds these abstractions, which are grouped into relations that represent types of entities and relationships between entities. New relationships among entity types may be added as the design progresses. The bottom-up approach is appropriate for the design of simple database with a relatively small number of attributes. The process of generalizing entity types into higher-level generalized superclass is another example of a bottom-up approach. The bottom-up approach has limitation of applying to the design of more complex database with a large number of attributes, where it is difficult to establish all functional dependency between the attributes. Here, as you can see from this diagram, first you are going to identify your attributes, then you are going to identify your entity. The third approach is called inside-out. The inside-out database design approach starts with the identification of a set of major entities and then spreading out to consider other entities, relationships, and attributes associated with those first identified. The inside-out database design approach is a special case of a bottom-up approach. where attention is focused at a central set of concepts that are most evident and then spreading outward by considering others in the vicinity of existing others. Yeah. Like, see the example. First you have to identify the department, and then you have to identify the branch, which are the main ones here, and then the employee, and then the project. The last approach is called mixed approach. Uses both the top down and bottom up instead of following a particular approach of various parts of the data model before finally combining all parts together. In this case, the requirements are partitioned according to the top-down approach, and part of the scheme is designed for each partitioning according to a bottom-down approach. Finally, all the scheme parts are combined. When you are doing the design of the database, there is what we call data model and data modeling. The data model organizes data elements and standardize how the data elements relate to one another. While data model is the process of creating a data model for an information system by applying a formal data modeling techniques. For example, in data model, here are the examples. In the logical level of designing a database, there is this model called relational model, which is like you are going to form your entities, your attributes and relationships in the logicals. Whereas in the conceptual, you are going to use the ERD, which are two different models. The phases of a database design. There are three phases of a database design, which are, the first one is called conceptual database design. Conceptual database design is the process of constructing a model of the data used in the organization independent of all physical consideration. In this stage, we are going to use the entity relationship model and enhanced entity relationship model. There are some words that we are going to use mostly here, which are the entity, relationships, attributes, multiplicity, cardinality, constraints. Yeah, for example here, let us see this example. This is our entity relationship model. For example, this is studio. This is our entity. The attributes are here: the studio name, address, studio contact. And then there is also another entity called movie, which has the attributes title, year release, length, genre. Each entity must have one primary key, and it must have one primary key. And the relationship between the movie and the studio is that the studio produces movie. So we have already understood that this is our entity, this is our attributes, this is the relationship, this is the other entity that's called movie. And so we are going to see our multiplicity. Here is our cardinality, 1 to 1. We have three cardinality. We have three cardinality mostly. It's like 1 to 1 relationship, 1 to many relationship, and then many to many relationship. For here, what we can see is that it's 1 to 1. It says like one movie is produced by one studio. Okay, and this one says one studio produces one movie. Okay, let us consider this one also. Director and then movie. The relationship between the movie and director is directors a movie. So the primary key for director is the director ID. The multiplicity is that one movie is directed by one director, and then one director directs many movies. I think it's okay now. The second phase for a designing database is called logical database design. It's the process of designing the database, but does not take into consideration which database system will be used or which hardware platform the database will be running on. The model that we are going to use here is the relational model, which is used to draw information from the conceptual phase. Relational database is a collection of data items organized as a set of formally described tables from which data can be accessed or resembled in many different ways without having to organize the database tables. Let us see this example. Here we have the relational model. The terminologies that we used to use in the conceptual level or the ARD model is different from this one. Okay. Sorry. ID. Tuple is a row of relation. Cardinality is the number of tuples in a relation. And then degree is the number of attributes in a relation. Attribute value is the domain. Domain can be is the domain. For example, there are some rules we have to consider in relational model. For example, for attribute, if a primary key is for a foreigner key to be in this relation, it must have to be it has to be a cardinality in a cardinality of some tuple. For example, the employee ID is 370. For a primary key, project ID will become the foreigner key for here. Okay, for physical database design, it's a representation of a database design which takes into account the facilities and any constraints of a given database. It describes the base relations, while organizations and indexes use it to achieve efficient access to data. I think we have all have idea about the database, and we are going to stop over here today. Thank you for you, and you may subscribe my video if it's